Okay, so we are going to review what is the Pythagorean theorem. Now, Pythagoras, an ancient Greek mathematician, discovered that if I have a triangle, like the one you guys see off to the right, and this needs to be a right triangle, it will not work with other triangles, so if I have a right triangle, that the square on A plus the square on B has the exact same area as the square on C. C is called the hypotenuse. A and B are called the legs. So let's go ahead and write down a few definitions. The legs. Okay. Our legs are just the sides that make the right angle. Okay, so get that written down before you move on. I'm just going to erase this now. When you guys need for things to slow down, that's when you need to simply pause this video. Okay, so next thing we're going to need to write down is the word hypotenuse. Okay, I know, nice large word. The hypotenuse, this is the side opposite the right angle. Now that means that our hypotenuse is C. Okay, this is also always the biggest side. So once again, get that written down. Okay, next, I'm going to go through a few examples with you of how to solve using the Pythagorean theorem. There are situations in which we need to be able to use the Pythagorean theorem to find the distance of an unknown side. So let's go ahead and start with the most famous numbers in the Pythagorean theorem. This is a right triangle in which the first side is a 3 and the second side is a 4. So we're going to use the Pythagorean theorem, which states that a squared plus b squared is equal to c squared. Okay, now my a, which is one of my legs, we called it 3, so we're going to have 3 squared plus b squared, which was 4, is equal to c squared. Now I don't know what c is yet, but through the process of solving equations I can figure out what that is. So 3 squared, that's a 9, plus 4 squared is 16, is equal to c squared. Still, we haven't changed c squared. 9 plus 16 is a 25, which is equal to c squared. Now, I just want to know what c is. I don't want to know what c squared is. I want to know what c is. In order to figure that out, I'm going to take the square root of c squared and the square root of 25. Remember, whatever we do to one side of an equation, we do to both. Now, when I take the square root of a squared number such as this, square root of c squared, the square root and the squared cancel each other out, and all I'm left with is my c. Square root of 25 is a 5. Square root basically asks what times itself is equal to the number inside. So, what times itself is equal to 25? 5. Okay, so this is one example. Now, I'm going to give you another problem, and you will need to follow these steps as well and write down the answer in your notes. You should have written down this one. If you didn't write this one down, go back, write it down, make sure to pause the video at the appropriate places. So, now we're going to have a triangle in which we've got 6 and then 8, and I need to figure out what that missing side C is. Okay, so I'll get you started out. First we begin. A squared plus B squared is equal to C squared. Before you continue watching this video, solve what is C squared using the example we just did. Okay, so since you're playing again, I'm assuming you've already paused and you've solved for this problem. So now we're going to replace A with 6 squared plus 8 squared is equal to the C squared. 6 squared is a 36. 8 squared is 64. Once again, 6 squared means 6 times 6. 8 squared is 8 times 8. That's where these numbers are coming from. And once again, C squared remains the same. We haven't done anything to it yet. 36 plus 64 is 100, so C squared is 100. But once again, we don't care what C squared is. We want to know what C is. So I'm going to take the square root of both sides. The square root of C squared is just C. Square root of 100 is a 10. Okay, so let's go ahead and erase that. Now there are some times in which we are already given the hypotenuse, or in other words, we don't know what one of the legs are, such as A and B. And so we are going to now look at an example of when we have perhaps B and C, but we're missing A and we need to solve for it. So our next triangle that we'll work with, we will give it B, we will call 5, so it has a length of 5 centimeters or something along those lines. C is a 13 and A is an unknown. Once again, we are going to begin with just writing down the Pythagorean theorem. A squared plus B squared is equal to C squared. I don't know what A is, so I can't change it. I'm just going to leave it as A squared. Plus B squared, B was a 5, so I now have 5 squared, is equal to C squared, 13 squared. Okay. A squared plus 25 is equal to 13 squared, which should be 169. Alright, so now I just have to figure out what that missing side A is. This requires me to remember a bit about solving equations. I want to get A alone, so I'm going to focus that on the things that are on the same side as A, namely that 25. To get rid of a plus 25, I subtract 25 from both sides. That gives me an A squared is equal to 144. I don't want A squared, I want to know what A is, so I'm going to take the square root of A squared, take the square root of both sides, you can't just do it to one side. Square root A squared is A. Square root of 144, stop and think for a moment. What times itself is 144? The answer is 12. Alright, so I will give you one more example. Feel free to use a calculator to help you with some of this. And once again, I want you to go through, use the example we just did to solve the next problem. Okay, so the next problem we are going to use 7 and 25. Once again, since we're dealing with the Pythagorean theorem, everything is A squared plus B squared is equal to C squared. Okay, so you should have already figured it out. If you haven't, press pause. Okay, so A squared is 7 squared. We don't know what B is, so that stays the same. C squared is 25 squared. Alright, so I know that my 7 squared is 49. We leave that B alone. It remains as B squared. 25 squared is going to be equal to 625. Now I need to get B alone. I see that 49 on the same side as the B. To get rid of that positive 49, subtract a 49 from both sides. So B squared is going to be equal to 625 minus 49, which is 576. I want B. I don't want B squared, so I got to take the square root of both sides. Square root of 576. This is where your calculators come in handy to do the square root. Okay, so B is equal to the square root of 576, which is 24. Now, on your assignments, you are going to run into situations where you are asked for a decimal. Please round these to the nearest hundredth, which means I want you to round them to 2 decimal places. When you encounter word problems, the best idea is to simply draw a picture of it. I'm going to give you guys a quick example straight from the homework. So in 8.2a, on number 12, the question reads as follows. Samuel places a ladder against the house. The base of the ladder is 6 feet from the house and the ladder is 10 feet long. How high above the ground does the ladder touch the wall of the house? Okay, so it's not terribly clear, and it's not terribly clear how we're going to find it. This is why we draw the picture. So, as silly as this seems, here's my little house. Okay, there is a ladder that is leaning against it, and we're going to draw the ground underneath it. So my ladder, the story said, was 10 feet long. Now it also said that my ladder was 6 feet away from the house. And I wanted to know, oops, let me erase that. I wanted to know how high was the ladder touching the house. Okay, so this is what we are trying to find. So you guys can see now that we actually have a triangle that we've already worked with, 6, 10, and I need to figure out what B is. You guys can use your notes, you can figure that out. With all of those questions, I suggest you use the Pythagorean theorem. You draw a picture, and then it'll become easier. Okay, that concludes these notes. You can now begin working on 8.2a, build Pythagorean theorem review and practice. If you have any questions, please go to the discussions tab and start a discussion about which question you have. I will try and respond to all of those, and I may respond with another video. Thank you for listening.